Hi everyone, and welcome to my presentation on weathering. So what is weathering? Well, weathering is basically the physical disintegration and chemical decomposition of rocks. Weathering is a very slow process, but it's a vital part of the rock cycle. In this presentation, I will talk about the different categories of weathering, like mechanical weathering, chemical weathering. So there are two different categories of weathering, which are chemical and mechanical. We'll get more into this in a second, but as a quick description before we move on, um, mechanical weathering can be defined as rocks breaking apart because of physical things like wind, etc. An important thing to remember is that mechanical weathering does not change the mineral composition of the rock with the weathering. That's chemical. So next, chemical weathering is the changing of the molecular structure, basically when a rock transforms into new compounds. Alright, so now I'm going to go more into the specifics of each category of weathering, starting with mechanical. So as mentioned previously, mechanical weathering causes rocks to be broken down while still keeping their same composition and characteristics. So here's a couple of very obvious examples of mechanical weathering. Now let's talk about the flow processes that lead to the breaking down of rocks. So first up is soil crystal growth. Soil crystal growth occurs mainly in places where there are rocky shorelines and places with little precipitation. It occurs when seawater gets into the crevices and pore spaces in rocks, and when that water evaporates, the salt crystals then form. So the crystals then become bigger, which pushes against the rocks and makes those pre-existing cracks even bigger, and that can be shown in the model picture below. Next is frost wedging. So this happens when water gets into the cracks of rocks. And then the freezing water expands and makes those cracks bigger. This creates angular fragments, as can be seen in the example there. It also occurs when moist soil freezes in a process called frost heaving. As more water gathers and then freezes, the soil is moved upward. The growth of the ice gradually causes the rocks to fracture due to the weakening that comes as a result of the frost wedging. Next is biological activity. So biological activity is another way that rocks can be broken down. So some of examples of what that would be like plants growing into rocks and causing them to fracture, or animals burrowing. That specifically causes the breaking down of rocks, but also when they burrow, they move material to the surface where it can be weathered by other processes. And also humans also contribute to breaking down of rocks very often when doing things like construction or mining, which can be seen in the picture right there. Alright, so next is sheeting. So sheeting occurs when rocks are exposed to weathering and slabs of the rock start to break off. This happens during the process of unloading when there's a large reduction in pressure as a result of the overlying rock being eroded. And there's some examples. Alright, so now let's talk about chemical weathering. It's important to note that the breaking down of rocks in a mechanical weathering process will ultimately help to make the chemical weathering process easier and faster because the rocks will already be in smaller pieces when the chemical weathering starts. So during chemical weathering, the internal mineral structure of a rock is changed by removing or adding elements, which is something I mentioned previously. So some examples of chemical weathering are hydrolysis, hydration, carbonation, oxidation, and acidification. So here's some pictures that show examples of specific chemical weathering processes. First up, I'm going to talk about water and carbonic acid. So water is basically one of the one of the most important parts in the process of chemical weathering. So pure water is non-reactive, but the oxygen that can be dissolved in water can oxidize some materials. Carbon dioxide dissolved in water will create carbonic acid, which decomposes rocks, and there's some examples. Uh, Next is spheroidal weathering. So this occurs when the sharp edges of the rocks are chemically weathered faster than flat rock faces are. So the more surface area that a rock has that at the edges and corners means there is more mineral material that'll be exposed to chemical weathering. Also, faster weathering at the edges of rocks will make the rock will make it so that the rock eventually becomes more sphere shaped, which can be seen in that example right there. Now let's talk about the rate of weathering. So an important thing to remember is that the composition of the rock greatly affects the rate at which it breaks down in chemical weathering or mechanical weathering. So different rocks will react differently to different types of weathering. And also the outside physical forces that damage the rock also can change the rate at which the rocks weather. Rocks weather faster in places with lots of heat, which drive reactions, and water that can help facilitate those reactions.